Hello class. Today we're looking at section 3.6 functions. A lot of vocabulary in this section. So turn to page 204. My first definition is a relation. It says a set of ordered pairs such as these, and if you have your book, you can see different sets. It's called a relation. A relation can be anything. You may have siblings, and you may have different ages. So you may have your big brother is 30. Okay, you might be 21. You may have a little sister that's 18. So that can be a relation. You can have the older brother is 30. I am 21, and I might have a little sister that's 18. I think I said 18. I don't know. But that's a relation. But you write it as an ordered pair. X will represent the names of you and your siblings. The Y values represent your age. Or you may talk about how tall someone is. So you may have your brother may be 6'4". You may be 5'6", and your little sister may be 5'5". That could be a relation. So a relation consists of an X, comma, Y, but it could be multiple things going on. And it can talk about different things. So that's a relation. But also look at your example of what a relation looks like on page 204. We will also look at a relation when we get to our problems. Domain. We talked about the word domain in chapter 6. Domains is what's going on with the X values. So domains represent the X values. We also talked about some other things with domain. Domain cannot be undefined. That would be something like a number divided by 0. So domain cannot say something like 2 over 0. And it cannot be imaginary. But you will talk about imaginary numbers when you get to your next math class, which is more than likely Math 112. You'll talk about imaginary answers there in more detail. A range. Range says, what's going on with my Y values? So range is what's going on with the Y values. A function. Next page. Now we know we see function, we think of f of x. And we know f of x is just like saying y equals. It says when each first component in a relation, your first component will be your x values. In a relation, there corresponds exactly to one second component, that's your y value. The relation is called a function. The definition of function is very tricky, but I'm going to explain to you in a much easier way so you'll understand what a function means. We talked about function in chapter 6. A function involves an input and an output, but we're going to go a little bit more in depth about what the word function means in this section. The definition of function, it says a function, okay, I'm going to read the definition that's in green. A function is a set of ordered pairs, a relation, in which to each first component there corresponds exactly one second component. Okay, so very, very easy. It says y as a function of x. So write that down. Y is a function of x. That's the second green box on page 205. And any equation in x and y where each value of x, the input, determines exactly one value of y, the output, is called a function. In this case, you say that y is a function of x. The set of all input values x is called the domain of the function. The set of all output values of y is called the range of the function. Sounds tricky, but as we go over it, we'll understand it. On page 206, you have the definition of a linear function. It says any function that is defined by a linear equation is called a linear function. A linear equation is something that makes a straight line. Where it's diagonal, it rises or falls, And then you have constant functions, but that falls pretty much under linear function. Is well, only one of them will fall under linear function. The one that's horizontal, y equals a number. The x equal number won't fall under linear function. So if it's something that says y equal mx plus b, and then we want to jump ahead a little bit, if it's something that says y equal a number, like y equal 2, that can all work under a linear function as well. X equal 2 or something, that would not work as a linear function. So be very careful with that. And we'll see why when we start talking about the vertical line test. Then on page 208, we're going to talk about the vertical line test. And this makes everything that I said super easy. The vertical line test makes all of what I said super easy if you know how to do the vertical line test. The vertical line test can be determined whether the graph of an equation represents a function. If any vertical line intersects, cross, touch, meet, intersects a graph more than once, the graph cannot represent a function because to one number x, there will correspond more than one value of y. We will talk about that today as we do our demo. So you're going to see me using a website called Desmos. If you have your your cell phone or another device that you can look at, go ahead and type in Google Desmos. You also can download an app for Desmos on your graphing calculator. On your cell phones, you can download the app, install your app Desmos. That will help you so much. And this website will also help you a lot when you go into Math 112 for those that have to take it. Now, turn to page 210. So we have gotten our vocabulary out the way. I just read it, but as we do our examples, I'm going to explain these vocabulary terms in much more detail. But just write them down for now. Page 210. Look at number 22. It says, find the domain and range of each relation. My relation is 3 and 7, -2 and -5, 3 and -1, 2 and -5. A relation is just comparing something. You may have multiple, the same thing, and you're trying to compare what's going on with those things. You can talk about, okay, I can have a student that has an A in the class, another student has a B, another student has a C, and another student may have an F in the class. Anything where you can kind of compare and contrast different data, that involves a relation, X and Y. When we're talking about domain is only the X values because that's what we said. Domain represents X values. To write my domain, I'm going to just pull out all the X values. I'm going to put it in numerical order, but it doesn't matter. But numerical order, I'm going to say -2, +2. I see 3 twice, so just write it one time. And that's my domain. All the X values. My range is all of my Y values. So I'm going to write it in numerical order also. -5. Write it only one time. -1. And then +7. And that's my range. Look at number 23. 23 says, determine whether the equation defines y to be a function of x. We read a lot with that vocabulary. So let's see, can we figure it out? 23, I have y equal -x plus 1. So for this one, we talked about all those different vocabulary terms, but I told you all that if you do the vertical line test, that makes everything I said so much easier. So if you have an additional device, or you can just go back and forth on your phone, let's go to Desmos. So Google Desmos, Desmos. So I'm going to cover that problem up because I want to get on Desmos so y'all can see it with me. So I'm trying to make it as easy as possible. Now, you see you have a wrench at the top right. Click on that. And then click on projector mode. That just makes the graph a little thicker so you can see everything a little better. Go here. It's a little blurry, so just work with it. If you're doing it with me, you should be fine. I'm going to say y equals minus x plus 1. So on your keypad, you should see a keypad right here. You should see a keypad. Okay? So you're not going to be able to see everything that I'm doing, but just listen to me and do it on your own. You can figure it out. So I have y equals minus x plus 1. And then your line should look just like my graph. Your graph should look like mine. I'm going to move my graph up just a little bit. And I'm going to move my equation, my function, out the way. Now, they want to know, does y represent, is y to be a function of x, is based off that vertical line test. I'm going to do a little math, but I want to look at the graphs first. And then we're going to do just a little math on some of these so you can see why it's a no. But if you do the vertical line test, that makes it so much easier. If I do my vertical line test, we know vertical line means it goes up and down. How many times does my red pencil intersect my blue graph? It only intersects one time. Okay, if you're not confident about the answer, do it again. How many times does my red pencil cross the graph? Only one time again. Many times you need to. It only crosses one time. So, if the vertical line intersects my graph one time, it is a function. So because my vertical line intersects that graph one time, it is a function. So my answer for number 23 would be yes, it is a function. Or the more formal way of saying it, y to be a function of x. So that's a yes. Let's graph 24. 24 says y equals 1/2 x minus 3. We're going to do a little math on this also, but let's just do the graphs. Don't be afraid of the graphs, okay? Because they're very easy to type in on Desmos. If you have a graphic calculator, you just go to your y equal on the graphic calculator and then just start typing everything in. Now, let's try it again. So delete this graph. I don't want that graph anymore. Or you can turn it off. That's how you turn it off. Just click on that circle. That'll turn it off. So I'll just turn it off and go to number 2. I'm going to say y equals 1/2. Move the cursor to the right and write x. And then minus 3. Y equals 1/2. Move the cursor to the right, x minus 3. And I see my graph. Complete the vertical line test. How many times does my vertical line intersect that graph? The red touched the green one time. That means it is a function. So my answer for number 24 is yes, it is a function. Let's do the math on this right quick. We'll go to the next example. If y equals only one solution, it's a yes. That's it. I would know 2 answers there if I see plus or minus. If I see plus or minus, I know it's 2 answers there. Then it'll be a no. But as long as I don't see y equal plus or minus whatever else, it's a yes. So y equals one part, y equal one answer, it's a yes. When you talk about functions, it's a little, the way you read it and the way you interpret it is a little backwards. But when I do my next graph, you'll kind of understand what I mean when I do my next example. X can only correspond to one y value. If the same x corresponds to more than one y value, it is not a function. That is what the definition is saying. So keep reading that definition until you understand what it's saying to you. And look at the graphs to confirm what you're reading. Let's try number 25. 25, I have x equal negative y squared. I want to do the math first and look at the graph second. Right here on numbers 23 and 24, y was already solved for. 25, y is not solved for. So let's solve for y. I'm going to just flip everything around and say negative y squared equal x. I'm going to divide both sides by negative 1. So I have y squared equal negative x. The next step I'm going to do is I have to get rid of that y squared. So to get rid of the square, I got to square root both sides. So I'm going to have y equal plus or minus. It's two answers there. The square root of negative x. I'm not going to go deep into this part. I only want to stress that I see y equal plus the square root of negative x and y equals negative square root of x. I see two answers there. So if I see y equals two answers, it is a no. That means that that same x is going to correspond to two y values. And it can't do that. That also means that it does not pass the vertical line test because the vertical line touched the graph more than one time. That might not make a whole lot of sense, but the graph helps you understand the why. So graph it and look at it. But if I see y equal plus or minus, it is no. That's it. Don't worry about doing the rest of this math. If I had to say plus or minus, it's a no automatically. Okay, let's graph it and let's see that no. So I'm going to turn this one off, or you can X them out if you don't want to look at those problems. Type it in just like the book wrote it. The book said X equals minus y, and it hit that a squared button. Okay, you have an a squared button here. So make sure you a squared to say y squared. Okay, let's move some things around. And then you just take your finger and move your graph however you want to move it, okay? Now, do your vertical line test. How many times does the vertical line touch my graph that's in purple? My graph's in purple. It touches it here and there. It intersects here and here. Two places. If it does that, that means it is not a function. Okay, now, I said something else. The same x cannot correspond to two or more y values. Let's test the x. I'm going to use, and we got to know how to read all points now, very important. I want to look at negative 1, 1, and negative 1, negative 1. So let's do it. I'm going to do a table. So right here, I'm going to add, okay, let me make sure you can see it. I want to add a table. So I want to look at, okay, yeah. Go back home. I want to look at negative 1. So I'm going to say minus 1 and 1. Then I'm going to say positive 1 and 1. No, positive 1 and got it backwards. I want to look at negative 1 and negative 1 again. I want to look at that. I don't know if I did it right because the points should hit the graph, not outside the graph. All right. Look at this. What do you see? I see the same x corresponding to two y values. It cannot do that. If I see that x value repeat itself, it is not a function. It doesn't matter what y says. Y can have the same number. X cannot match. So think back at number 22. Would 22 be a function? No, 22 would not be a function because 3 corresponds to 7 and 3 corresponds to -1. I cannot see my x value repeat. If I see my x value repeat, it is not a function. If none of that makes sense, it didn't pass the vertical line test. That's why it's a no. Let's try another one. Let's graph number 26. So 26, I have x equal to absolute value of y minus 1. Let's graph this one. Think about the word, what's the definition of absolute value? So you want to write that as one of your vocabulary terms also. We know that absolute value is the distance from 0. So if I say x equal to absolute value of 2, well, what numbers are 2 units from 0? -2 and +2. So let's talk, I want you to think about that as we do this one. When you talk about absolute value is going to have 2 answers in there. Now look at this one. I'm going to do x equal, you have 2 vertical bars and an A in between it. The bar is right there. You'll hit that button. And then we'll type in y minus 1. Look at the graph. Look at your graph. Move it over so you can see it. Does it pass the vertical line test? No. It intersects here. I can do it in multiple places. I can just slide all the way across. It's touching that graph twice. You know, right here is one time, just at that end, that point right there, where that vertex is. Don't let that confuse you. What a majority is. The majority does not pass vertical line test. Okay, it does intersect right at this vertex, but everywhere else it doesn't work. It's a no. So my answer for number 26 also will be no. So what does this mean? This means that I have an x that corresponds to exactly 2 y values. Let's see that. Let's see if that makes sense. Okay. So if I was to taking the square root of both sides is easy to look at because it'll say plus or minus. This one right here, I'm going to do a little more mental math on 26 to explain the no. So right here, when I think about x by absolute value, whatever comes out of absolute value is going to be positive. So just say, for instance, I want to let x be 2. What would make this answer equal to? I can use 3. So 3 minus 1 is the absolute value of 2, which is 2 equals 2, right? But I also know that if I do a -2 and I take the absolute value, that's going to still give me positive 2. So let's find another value for y. If I say 2 equals, and for example, I want to say -1. The absolute value of -1 minus 1 is 2 equal to the absolute value of -2. But the absolute value of -2 is 2. So this means that 2 corresponds to 3. And 2 also corresponds to -1 for y. So I see that x twice. I can't see that. I don't want to see x twice. I did an extra step already on Desmos. So right here, I'm showing you that on my table, I go to the plus sign and do table. If I do 2 and -3, I'm here. If I do 2 and -1, I'm there. And then when I do my vertical line test, I see that doesn't work. It's a no. Okay, so on numbers 41 through 44, look at those. On 41, so I want to go ahead and jump ahead and look at the vertical line test, and I'm going to go on from there. Does that pass the vertical line test? Yes. 42. Does this graph pass the vertical line test? That's a no, because it intersects in more than one place. 43. Does this graph pass the vertical line test? And that's a no. 44. Does this graph pass the vertical line test? That is a yes. So, very important. I do want to ask you a trick question, and you tell me what you think, yes or no. If I gave you a vertical line, does the vertical line pass the vertical line test? That vertical line is touching that graph infinitely many times. So this would be a no. And when I read the definition about linear functions work when the graph is increasing and decreasing and when the graph is horizontal. But if the graph is a constant function that's vertical, it's a no. But on a horizontal function, it'll be a yes. It does pass the vertical line test. This is a no because the graph and the vertical line, they coincide. That's why it's a no. Right here, it's a yes because it only intersects that graph one time. The 2 became 1, so it's a no. It still intersects only one time, so that's a yes. On the vertical line, put some points on your graph and look at that all the x's repeat. The x's can only appear one time. Okay, look at number 29. It says find f of 3, f of 0, f of -1, f of x equal 3. Again, we know f of x is like saying y. F of 3. My original function is 2x minus 3. If you are comfortable with decimals, you can look at the graph and tell me when x is 0, when x is 3, what's your y value? That's how you find it. So if I say f of 3, you can graph this function. When x is 3, what's the y value? That's how you can find it very easily. But if you don't want to look at the graphs, just plug it in. I'm inputting 3 for x. So I have 2 times 3 minus 3. 6 minus 3 is 3. F of -3. Bring down to 2. -3 for x. Bring down to -3. 2 times -3 is -6. Minus 3. Signs are the same. Add. Keep the sign. So -9. My input is -3. My output is -9. F of -1. Okay, I jumped ahead somewhere. Okay, I jumped ahead on that one. So this was a mistake because that wasn't in direction. But it's okay. It's good practice. Let's do f of 0. Going back to the directions. Got to deviate a little bit. We have 2 times 0 for x minus 3. 2 times 0 is 0. Minus 3 is -3. Stand on the directions. F of -1 equals 2 times -1 for x minus 3. So -2 minus 3, -5. So except disregard the f of -3 because that wasn't in the original direction. But it's just good practice, so it's okay. Now let's do that last one. I'm going to erase this so we can look at the last one a little bit more detail. It says f of x equal 3. I know f of x represents y. So in my original problem, I'm going to plug in 3 where f of x is equal 2x minus 3. And I'm going to solve for x. I'm going to add 3 on both sides. So these 3 will go to 0. I'm left with 6 equals 2x. Divide both sides by 2. So x equals 3. That one's a little different because they gave me y, so they want me to find x. So that one's very different than the others. They gave me the output, and I had to find the input. So this one represented your output, and they wanted me to find the input. Whereas the first example said they gave me the input, and I had to find the output. Okay, so that is all I will cover for section 3.6. We are going to talk about domain and range, but I will cover domain and range when we get to chapter 9. When we get to 9.1, we'll talk about domain and range. And then you'll probably see me going back to this section to talk about it a little bit more detail. One thing I want to stress about domain again. Domain cannot have an undefined answer, and it cannot have an imaginary answer. If it has those two answers, I will have some domain issues. But when you get into Math 112, you get into calculus, if you're taking those maths, you will really get in depth with what domain is talking about. But the main thing I need you to know for this class is I don't want my answer to be undefined. And I don't want any imaginary answers. And if I see a denominator, I'm going to have some undefined answers. I'm going to have some problems. I also want you to remember about domain is that domain represents the x values. Range represents my y values. So those are the main things I want you to take away from domain and range for now. And we will look at some more graphs and talk about that in more detail. Okay, I know this is a little bit more trickier, so just please continue looking at your notes. If you have any questions or concerns, let me know. And then look at some additional notes online. Just type in the topic on YouTube and you can find a lot more notes to help you understand the material much better. Okay, study.